Hello everyone, welcome you back for the sessions on the fluids for the hydraulic power systems. Normally, the important materials in the hydraulic system is the working fluid itself. The fluid what we are using, normally it should be a petrochemical or it should be an oils only. The hydraulic fluid characteristics have a crucial effect on the equipment and as well as the performance of the system and also life of the system. It is important to use a clean high quality fluid in order to achieve the efficient high hydraulic system operation. The different types of the hydraulic fluids normally which are used in the hydraulic systems are the water is one of the simpler where the low viscous fluid which is used as a hydraulic fluid in the system. The least expensive hydraulic fluid is the water. The water is treated with chemical before using it in the fluid power system, because as we know that the most of the water what we are obtaining it may be a contaminated, or it may contains some chemicals, or it may be the salts. These salts may corrode the system, or these salts may affect the system operation. For that reason only this it has to be treated and it has to remove the undesirable contaminants. The next one is nothing but the petroleum oils. This is the most common among the hydraulic fluid which is used in a wide range of the hydraulic application. The characteristics of the petroleum is based on the hydraulic oils are controlled by the type of the crude used, especially the oil. In the case of the petroleum oils, the viscosity is changing it. That depends upon the type of the oil what we are using it with respect to the system. A uniform, or it may be what we can say a ideal viscous fluid, is most essential in the system to have a efficient and a good life fluid power system. Even water glycol can also be used as the hydraulic fluids. These are the solutions which contains 35 to 50% of water, glycol and water soluble thickeners to improve the viscosity. Additives are also added to improve the anti-corrosion and as well as the anti-wear and as well as the lubricity property for the oils, especially for the water glycol. Water oil emulsions are the oils water oil mixture. Even in these also there are two different types of oils are there: oil in water emulsion or water in oil emulsion. The oil in water emulsion has water as a continuous base, and the oil is present in a lesser amount and in a dispersed media. In the water oil emulsion, the oil is a continuous phase, the water dispersion is less in the media. The water oil emulsions, either it may be the water based or it may be oil based. These emulsions and as well as the water glycols are somewhat cheaper when compared to the petroleum oils. The next one is nothing but the phosphate ester. It results from the incorporation of the phosphorus into an organic molecules. They have a high thermal stability. They serve as an excellent detergent and prevent a building up of the sludges. These phosphate esters are can also be used as a hydraulic fluid in the fluid power system. The main advantage of this is it prevents the building of the sludges. But in the normal, either it may be in the case of the petrochemical or it may be the petroleum oil, or even in the case of the water oil emulsions, or it may be oil water emulsions or water glycol, there the sludge formation is little more when compared to the phosphate esters. For a fluid to perform efficiently, it must be processed, or it should possesses a certain important properties. The various important properties which are required for the ideal hydraulic fluids are the ideal viscosity, good lubricity or good lubrication capability, demisability, good chemical and environmental stability, incompressibility, fire resistance, low flammability, foam resistance, low volatility, good heat dissipation, and low density system compatibility. See, these are all the important properties which are essential for a good hydraulic fluids which are used in the system. In detail, we are discussing the properties of the hydraulic fluids. The viscosity, it's a measure of the fluid internal resistance offered to flow. The viscosity is a major factor. Along with the viscosity index is also another major factor which is essential in the fluid system, especially in the hydraulic system. Why means, if there is a rise in temperature, it should not loses its viscosity. Once if the viscosity changes, means automatically the performance of the system will changes. This is a major factor that it has to be considered in the selection of the oils. Oxidation stability, the most important property of the hydraulic oil is its oxidation stability. The oxidation is caused by the chemical reaction between the oxygen which is dissolved in the form of a air in the oil, or maybe the oxygen content which is there in the chemical composition itself. See, the oxidation, it can be created because of so many reasons. Once if there is a rise in temperature, then the oxygen which is chemically inserted, or it may be chemically which is there in the material, can disintegrate and forms a oxide. Oxidation may takes place, or if not, the oxidation of the oil is created by the impurities like the sludges or insoluble gums, or it may be soluble acidic products. The soluble acidic products causes a corrosion, and insoluble products the malfunctioning of the operation, and as well as it is in the sluggish form. Demisability is the ability of the hydraulic fluid to separate rapidly from the moisture and successfully resist emulsification, which is known as demisability. Lubricity is a most important factor that it has to be considered in the hydraulic system. Any hydraulic fluid, it should be a lubricative type. As we know that either it may be a reciprocatory system or it may be a rotary system, the moving parts are there. These moving parts should work with efficiency. Means the lubricity is another parameter which is affecting the system. And also the wear and tear can be minimized by using a high-end lubricating oil. The rust prevention. The moisture entering into the hydraulic system with air, the parts made up of the ferrous material are prone to rust. This rust, if passes through the precision made pumps and as well as the valves, the wear and tear will take place, or if not, the noise will also be more. So inhibitors are added to the oil to keep the moisture away from the surface. The next, which is a important one, is nothing but the pour point. The temperature at which the oil will clots is referred to a pour point, the lowest temperature at which the oil is able to flow easily. See, as we know that the systems what we are developing, or it may be what it has been under use, it can be used, or it will be used in the high temperature application and also in the low temperature application, depending upon the climatic condition, and even the places where the temperatures are low, even there also these systems it should work. For at that particular point, the hydraulic oils, or it may be the oils normally what we are using, it should not clot, and it should have a high pour point. The same way, if the same system, if it is used in a high temperature application, there it should not evaporate and it should not catch fire. The another two parameters normally which what we are considering with respect to the properties are the flash point and as well as the fire point. These flash point and fire point is based on the temperature at which the liquid gives off the vapor in a sufficient quantity to ignite momentarily, or the flash when the flame is applied. The minimum temperature at which the hydraulic fluid will catches the fire and continues to burn. This is called as a fire point. These 2 points is also a major factor that it has to be considered while selecting a type of the oil in the system. Then the neutralization number. The neutralization number is a measure of the acidity and as well as or the alkalinity of the hydraulic fluid. This refers to a pH value of the fluid. The high acidity causes the oxidation rate in the oil to increase rapidly. Density. It is the quantity of the matter contained in a unit volume of the substance. The compressibility is also another major factor that it has to be noted in such a way that, as we know that most of the oils can be compressed, and on most of the systems or the hydraulic systems where the load is a major factor, and once if it is under working condition, the fluids are compressible to some extent. The compressibility of the liquid causes the liquid to act much like something like a stiffening spring. The coefficient of the compressibility is the fractional change in the unit volume of the liquid per unit change of pressure. Even the selection of the hydraulic fluids. The hydraulic fluids has the following four primary applications. The four primary applications are to transmit power, the lubricate the moving parts, the seal clearance between the moving parts, and as well as the dissipating heat. In addition to the hydraulic fluid must be inexpensive and readily available from the selection point of view, and also the hydraulic fluids should have the following properties: good lubricity, ideal viscosity, chemical stability, compatibility with the system material, high degree of incompressibility, fire resistance, good heat transfer capability, low density, foam resistance, non-toxicity, and as well as low volatility. See, as we know that if you start considering with respect to the viscosity, any viscous fluids, there are two different types of viscous fluids are there. One is the high viscous fluids, the another one is a low viscous fluids. But the fluids what we are using in the system, it should be a ideal viscous fluid, which is not a high viscous fluid or not a low viscous fluid. The high viscous fluid or the high viscosity, a high resistance to flow, increases the power consumption due to the frictional losses or the high temperature caused by the friction. The increase in pressure, the drop decreases the resistance. The possibility of the sluggish or the slowing in operation, the difference in separating or difficulty in separating the air from the oil in the reservoir, the greater vacuum and the pump inlet causing the cavitation, and higher the noise level. In the same way, if you start using the low viscous fluid, The increase in leakages and excessive wear, the possibility of decreasing the pump efficiency causing the slower operation of the actuator, and increased in automatically the cost because of the what we can say the leakages, or it may be the wear in the pumps because of the less lubricity. For that reason only, a fluid which is to be used in the hydraulic system should be a ideal viscous or a ideal viscous fluid. The ideal viscosity is the most basic desirable property of the hydraulic fluid is a optimum viscosity. It's a measure of the fluid's resistance to flow. When the viscosity is low, the fluid flow is easier. On the other hand, when the viscosity is higher, the fluid flow is a very difficult one.